All right, here we have a introduction to exponents and the natural logarithm. So we've been introduced to this number e, which is just 2.78, and it's a base that we're going to use in future. Now we have e to the power of k equals a, and k is equal to ln a. Now these things are linked together. Okay, so if e to the power of k equals a, we can substitute a into this equation. Okay, so from that we can get k equals ln, and we know that a is equal to e to the power of k, so we have ln e to the power of k. So basically what the ln does, the natural logarithm, is it cancels out the e. Okay, you've got the k here and you've got the k up there. All right, so if we have k equals ln a and we're putting this value for a into the equation, we can see that ln e to the power of k is just equal to k. There's one more thing we can deduce as well. Okay, here we have k is equal to ln a. So let's put this value for k into this equation here. We're going to have e to the power of ln a is equal to a. Okay, so two things we've deduced from this equation. K is equal to ln e to the power of k, and e to the power of ln a is equal to a. Okay, so two things linking these equations, and they can just be arranged to come up with these just by substituting the different information that we're given. Okay, this will become more clear the more you use it, but just keep staring at it till it makes sense. So we have write an equivalent statement for ln 0.9 is equal to, or approximately equal to, minus 0.105. So what that means is we're going to substitute this somehow and express it in terms of e. So at the moment we have ln a is equal to k. So the other way we could express that then is e to the power of k is equal to a. Now in this circumstance, our 0.9 here is a, and our minus 0.105 is k. Okay, it matches up with this formula here. So we can express that using this one. E to the power of k is equal to a. So e to the power of minus 0.105 is equal to 0.9. All right, and that's how we do that. We've just expressed it in a different manner. Okay, here we've got simplify e to the power of n on e. Okay, ln of e to the power of n on e. Now first we can see that we've got e to the power of n on e to the power of 1, and we can use an indices law to express this as ln of e to the power of n and e, I'll do it nice and slowly so that we can see that we're expanding, times by e to the power of minus 1. All right, and then from another indices law, we can see that this can be written as the natural logarithm of e to the power of n take 1. Okay, now we remember from before this point up here, okay, that basically the ln e to the power of k is equal to k. So ln e to the power of negative n take 1 is just equal to n take 1. Okay. Use your calculator to write in the form e to the power of x, where x is correct to 4 decimal places. Okay, so we have 6, the number 6, and we want to write it as e to the power of x is equal to 6. So what is this number x that makes e to the power of x equal to 6? Now remember, e is about 2.78. But what we can do here is just use logarithms to solve this one, the natural logarithms. Okay, so we remember from before, I'm going to write it again here so we remember that ln e to the power of k is just equal to k. So what we can do is apply ln to both sides. So we have ln of e to the power of x is equal to ln of 6, okay? And ln of e to the power of x is just x. X is equal to ln 6. So if we're going to write it in the form e to the power of x, then we're going to need to write it, we're going to need to calculate ln 6 and write it in that form. So using our calculator, ln is this button here, ln of 6 is equal to 1.7918. Okay, so to express that in terms of e, we can write it as now if we put this in our calculator, it should be equal to 2, equal to 6. Okay, because what we've solved is the value of x that makes e to the power of x equals 6. Our value for x was 1.7918. So let's confirm that. So let's go shift ln to the power of the answer that we got before. Exactly 6. Okay. We're then asked to do that with 60. Okay, so we're going to do the exact same thing. We have e to the power of x is equal to 60. What is the value for x? So again, we're going to apply the natural logarithm to both sides. So we have ln of e to the power of x is equal to ln of 60. Now, ln of e, those cancel each other, okay? And we remember that from the law up here again. So this just becomes x equals ln 60. We put ln 60 in the calculator. And we get 4.0943. Okay, and once again, to express this in terms of e, this means the final answer is e to the power of 4.0943 is equal to 60. All right, so we've solved that value of x. I'll just confirm it here again for you. Shift e to the power of, and we'll put just the answer that we calculated before. The answer is 60. Okay, so that's how we can use the law of logarithms in a bunch of different ways.